Let's look at question 1 in this video. So we have here a bank who wants to know the average monthly account balance of their customers. Now, a random sample of 145 customers gives us an average balance of $1,990.5. The population standard deviation for this distribution is $2,833.3. We want to calculate a 90% confidence interval for the population mean. Now, that interval is going to be the following, true or false. So we have the data over here. What's the idea of the confidence interval? Why do we do it? So the 90% confidence interval, of the population mean, we do it to find out a range of values that's going to include the population mean with a probability of 90%. Why is that? Because the sample mean is just an estimate of the population mean. This is just an estimate of the population mean. The sample mean is not equal to the population mean. So because they are not equal, we want to find out a range of values that's going to estimate, an interval where we can actually have the population mean included with a probability of 90%. So here we're going to have an interval that includes the population mean, so the mu, with a probability of 90%, with a probability of 90%. Now, how do we do so? We do it based on our sample data, because that's the idea of statistics. We use our sample data to estimate data for the population. So we're going to have the sample mean that we calculated plus minus a margin of error. What's the idea of this margin of error? Well, we could have the true population mean above the sample mean, or it could be below the sample mean. So we have to account for both options by adding a margin of error and subtracting a margin of error. How does the margin of error look like? Well, we're going to use the critical value z for the confidence interval of 90%, and that's equal to 1.645. We can find it in the z distribution. And by the way, why do you use the z value and not a different one? Because whenever we have large sample sizes, usually above 30 observations, we can use the z distribution. If this was less than 30 observations, then we would use the t critical value. Just a detail to keep in mind. And this one we multiply with the standard error. The standard error of the sample mean is equal to the standard deviation of the population over square root of n. Now it's a matter of substituting all the data. So what are we gonna have? Let me just zoom out first. We're gonna have the sample mean of 1990.5. So we substitute that. We have over here 1990.5 plus minus all of this math. So let's solve the math. We're gonna have, let me use the same colors, we're gonna have 1.645. So we're gonna have 1.645 times the population standard deviation, which is equal to 2833.33. So 2833.33 divided by square root of n means divided by square root of 145. Now if we solve the math over here, what do we get as a result? Well, we'll have the following range of values, which is the same as here, 1603.44 until 2377.56, and we include the extremities as well. So what we're saying is that in this range of values, there's the probability of 90% that we have the true population mean included. That's what it means. So the answer to this question is true, and we are done.